Recording in progress.
So you can also move this. So last class, what we discussed was Lorentz force, right? Ritika, are you able to hear me?
Sir?
Speak
Yes, sir.
again. Okay. So last class we were discussing about Lorentz force. In Lorentz force, we know that when a charged particle enters a magnetic field with velocity, what will happen to the charged particle? It starts experiencing a force of Q into V vector cross B vector. Correct? So this is what happens, right? Which we wrote it in the vector form. Or this will also be F vector is equal to Q into VB sin theta with an n cap, where the n cap is a unit vector perpendicular to both V vector and B vector. Right? Accepted? Now the question is, if I want to write only the magnitude, then I will write F is equal to Q into V into B sin theta. Correct? So it is going to be QVB sin theta, where you say theta is the angle between whom? Angle between V vector and B vector. Correct? So all these points we discussed in the previous class. Suppose if V vector is 0, means what is the meaning of it? If the particle was at rest and it is placed in the presence of electric field, then what does F vector represent? That will also be 0. Means the particle continues to be at rest. Okay. Similarly, if V vector is not equal to 0, but it is uniform, then what will happen to F vector? So, if V vector is not equal to 0 and it is uniform and the value of theta is equal to 0 degrees or 180 degrees, then what would have happened? The force on the particle in this scenario also would have been 0, but in this case, the particle continues to move with, yes, uniform velocity. When force is 0, the object will not accelerate. Right? Particle continues to move with uniform velocity. Right? Now, I have a question. That is about the special cases. If theta is equal to 0 degrees, 180 degrees, or sorry, theta is equal to 0 degrees or 180 degrees, what will happen to the particle? Means if there is a magnetic field of this sort existing, okay, and a charged particle is projected with velocity at theta is equal to 0 degrees or 180 degrees, what will happen to the force? Force will be 0, means the particle continues to move with uniform velocity. Okay, accepted. So particle continues to move with uniform velocity. The second scenario is if theta is equal to 90 degrees, what would have happened? If theta is equal to 90 degrees, let us consider a scenario like this. Let's say there is a magnetic field which is existing into the plane of the paper. Okay, and there is a charged particle projected with velocity v at an angle theta is equal to 90 degrees. Okay. So once it starts entering the field, what will happen is F will be equal to Q into V into B into sine 90 degrees. Correct? So sine 90 is going to be 1. So it is going to be QVB. So this is the value of force. Right. Now another question that we are supposed to answer is, when you're doing the cross product between velocity vector and magnetic field vector, how is F vector? How is F vector with respect to velocity and the magnetic field? Yes. So F vector is perpendicular to both B vector and B vector, except when this is going to be the scenario. As soon as the particle enters, the velocity of the particle will still be like this, but the force is going to be perpendicular to it. Correct? When this is the case, will the particle experience a change in direction? Yes, it is going to. So I will say that the particle is no more going to continue in a straight line path, rather it will start moving in a curved path. Now we need to answer what this curved path represents. What does this curved path represent? What shape does it take? How do you know that?
Sir, here does the particle start moving in the curved path?
Yes, because force and velocity are perpendicular to each other.
Okay, sir.
Yeah. Okay, curved path means it could have been a parabola also. Right? How do you know it is only centripetal force? That is the answer. So the only motion where F vector and B vector are perpendicular to each other at every instant, okay, is, what is it? Uniform circular motion. It is not circular motion. It is uniform circular motion. So when I say uniform circular motion, I'm trying to say that the particle is going to revolve, obviously in a circular path, in such a way that velocity vector and force vector are always perpendicular to each other. Right? When they're always perpendicular to each other, then what is going to be the radius of the circular path that the particle is going to take? R will be equal to what is what we need to find. Okay, for that, what we will do is force acting towards the center is what? force acting towards the center is Q into V into B, which is the required magnetic force, except, right? And we know that the force acting towards the center is what? Yes. So it is also centripetal force, and whose value is equal to how much? mv square divided by r. So let me call this as equation number 1. Let me call this as equation number 2. So the force that is the magnetic force which is acting on the particle is the one which is providing the necessary centripetal force. So can I write Q into V into B is equal to mv square divided by r? So V and V will get cancelled, which implies R is equal to mv divided by QB, and this is going to be the radius of the circular path when the charged particle is projected perpendicular to the magnetic field. Okay, so R is equal to mv by QB is going to be the radius of circular path when the charged particle is projected at how much value? Charged particle is projected at 90 degrees with respect to B. Okay. Now the next question is, if this is going to be the circular path, we found the radius. Let's say this is the place where the object is starting, the charged particle is starting. And for the particle to start at A and to come back to A, okay, for the particle to start at A and to come back to A, it takes one time period. So what is going to be the time taken by? Time is equal to distance divided by speed. So what is going to be the distance it covers in the time? It travels from A to A. It is 2 pi r divided by the speed is going to be v. So this will be equal to 2 pi into r is mv divided by qb divided by v. V and v will get cancelled. This will be equal to 2 pi m divided by qb. So this is the value of time period which will get generated. So t is equal to 2 pi m divided by q into b. Okay. So if you observe an important point here, it is independent of some physical quantity. What is it? No. Yes. So if you observe, time period is independent of velocity. So what is the meaning of this? Means with whatever speed you're trying to project the particle, if you're projecting the same particle of same mass into with different speeds at 90 degrees, the particle will take the same amount of time to complete one revolution. I repeat, same particle projected into same magnetic field will take same time to complete what? To complete a revolution. So here what will change? If the speed changes, the radius of the particle will change. Okay, the radius of the path will change, but the time period will be the same. So the radius will be adjusted in such a way that the time period will always remain as a constant value. Here, this is all about particle projected perpendicular to the magnetic. The next one that we are going to see is write down when it is projected at an angle. This is the third case. So case 3 is when theta is not equal to 0 degrees, 180 degrees, or 90 degrees. Means if it is projected at some random angle other than these three values, then what is going to be the path followed by it? So if I take a uniform magnetic field like this, if I take a uniform magnetic field like this, and if the charged particle is projected at an angle theta with respect to the magnetic field, okay, then what will happen is this V can be resolved as V cos theta and V sin theta, right? Now, this V cos theta, if you observe, is a parallel component. V sin theta is a perpendicular component. So from the first case, if you recollect, right, if there is a velocity component in the direction of magnetic field, what will happen to the charged particle? It moves in the, yes. So V cos theta will be responsible to put the particle in a straight line motion. V sin theta will be responsible to put the particle in a circular motion, because this is case number 2. So this V cos theta and V sin theta combined together will create a circular motion plus a straight line motion, where the particle will either have a completely circular path nor a completely linear path. Rather, it will have a combination of both, which will look in this format, which we call it as helical path. Okay. So this is what we call as helical path. And observe, if the particle has started from here and it has gone till here, okay, so this has covered some linear distance, right? So this linear distance is covered by the particle in how much time? So linear distance is covered by the particle in how much time? In time capital T. Correct? It takes one time period for the particle to go back, to start from a point and come back to the same point. If you observe, A and B are lying on the same horizontal level. But why is that A and B are not the same point? Because V cos theta has pushed it slightly away, right? So it takes one time period to complete this kind of a revolution. When that is the scenario, observe, then can I say AB is equal to speed into the time taken for this travel to happen? So what is the speed which is responsible for this particle to move? It is. And what is the time it takes for the particle to complete one time period? So it will be V cos theta multiplied with time period is 2 pi m divided by q into V. So this will be equal to 2 pi mv cos theta, the whole divided by q into V. And This distance AB, the horizontal distance traveled by the particle, is what is called as, it's called as pitch. PITCH. It's called as pitch. Done, right? Similarly, what is going to be the radius of helical path? So if you look at the formula for radius of circular path, it is R is equal to MB divided by QB. But here, this helical path also has a radius associated with it, which let me call it as capital R. Can I use the same formula here? So can I use R is equal to MB divided by QB? Yes, I can use it, provided I take only the perpendicular component into consideration. Because what did I tell you? The perpendicular component V sin theta is the one which is responsible for the circular motion of this object. When that is a scenario, I can write R is equal to M into V perpendicular divided by Q into V. Is it clear? So this will be equal to M into V perpendicular is V sin theta the whole divided by Q into B. So R will be equal to MV sin theta divided by QB. If you want, you can substitute theta is equal to 90 and see. When theta is equal to 90, what will happen to the path of the particle? Theta is equal to 90 degrees. Path of the particle is circular. So if you take theta is equal to 90 and substitute it here, R will be equal to MV by QB. Is this not the radius we derived for the circular path? Same logic. Is it clear? Okay. So we'll try out some problems based on this. If you observe example 4.2. So they are mentioning if the magnetic field is parallel to the positive y-axis. So magnetic field is parallel to the positive y-axis. And the charged particle is moving along the positive x-axis. Charged particle is moving along the positive x-axis. So this is V vector, this is J cap, this is I cap. Okay. Which way would the Lorentz force for an electron and proton act? So force on electron, what can I write it as? Minus E into V vector cross B vector. Right? It will be minus E into, what is V vector? V I cap cross B vector is B J cap. So I cross J is K. So EVB into minus K cap. So EVB is going to be the magnitude and minus K cap will be the direction along which the particle will experience force. So an electron will experience a force into the negative Z direction. Then what about a proton? So proton, use the same logic. Force on the proton will be equal to positive charge E into the same V vector cross B vector. What will we get? We'll get EVB into I cross J, which is going to be K cap. So proton will experience a force in the positive z direction and electron will experience a force in the negative z direction. Okay. Next. Let's try this. What is the radius of the path of an electron whose mass is 9 into 10 power minus 31 kilogram and charge is 1.6 into 10 power minus 19 coulomb, which is moving at a speed of 3 into 10 power 7 meters per second in magnetic field of 6 into 10 power minus 4 Tesla perpendicular to it. So R is equal to, you know, the formula R is equal to MB divided by QB. Okay, so I'll just give you the outline. R is equal to MB divided by QB. Okay. Similarly, calculate its energy in kilo electron volt. So, for a moving particle, what would be the energy associated with it? So, E is equal to half mv square. So, half into mass is 9.1 into v square is 9 into 10 power 7 meter square per second square. So, this comes out to be in terms of joule. Okay. And they're asking the answer in terms of kilo electron volt. Remember, 1 electron volt is 1.6 into 10 power minus 19 joule. They have given it. So what will 1 kilo electron volt be? 1.6 into 10 power minus 13 joule. 1 electron volt is 1.6 into 10 power minus 19 joule. 1 kilo electron volt will be 1.3 into 10 power minus 13 joule. Why kilo is, 10 power 3, no, it will be 10 power minus 16. It will be 10 power minus 16 joule, right? Yes, into 10 power 3, you do it on both the sides. So, since you are getting the answer in terms of joule here, to convert it to kilo electron volt, you need to multiply 9 into 10 power 9. You multiply this, you will get an answer, right? How much is the answer you are getting? 40.5. 40.5 into 10 power minus 17 joule. You have to divide it with 1.6 into 10 power minus 19, then you can write it in electron volt. If you directly divide it with 10 power minus 16, you can write it in terms of kilo electron volt. So if you want to convert joule to electron volt, you need to divide. If you want to convert electron volt to joule, you need to multiply. With what number? 1.6 into 10 power minus 19 joule. Okay. So when you solve this, the answer comes out to be 2.5 kilo electron volt. Is it clear? What is the? So you need to find the frequency, right? So you know the time period. 1 by time period is frequency. So time period is 2 pi m 2 pi m divided by qb. So what will frequency be? Qb divided by 2m. That's it. Okay. Now listen. The next concept that we need to discuss is velocity selector. Okay. Suppose you know that a charge q is there, which is moving with a velocity. You know that a charge q is moving with a velocity v in presence of both electric and magnetic field. Okay. So there is a charge q which is moving with a velocity v, okay, in presence of both electric and magnetic field, where the electric field and magnetic field are mutually perpendicular to each other, or else perpendicular to each other. Okay. If this kind of a scenario is existing, okay, and you want to project a charge particle mutually perpendicular to both the fields. Okay, you will project it perpendicular to both electric and magnetic fields. When you project it mutually perpendicular to both, then what will happen is, due to the electric field, the charge particle will experience a force of how much value? So there will be a force experienced in the direction of electric field of how much value? Q into the value of electric field, Q into E. And due to the magnetic force, where the magnetic force is taken along z direction and the velocity taken along y direction, using the formula Fb is equal to Q into V vector cross B vector, find out what is the direction in which the magnetic force will act, and tell me. So B vector is Vi cap, B vector is Bk cap. Solve it and tell me. So you will get I cap cross K cap, you will get minus J cap. So the magnetic force will be in the downward direction. So if you observe, in a scenario where the electric field and magnetic field, where electric field is along positive y direction and magnetic field is along positive z direction, if this kind of a scenario is there and the particle is projected along x direction, that is mutually perpendicular to both electric and magnetic fields, then there will be a scenario where the electric field, if it is in the positive y direction, the magnetic field will exactly be in the negative y direction. If the electrostatic force is equal to the magnetic force, okay, then can I write Q into E would have been equal to Q into V into B? Because Q into V into B, what would be the value of sine theta? 90. That is why I wrote it as QVB directly. Both will get cancelled. Then V will be equal to E divided by V. Okay. So first understand the context here. If the magnetic force is exactly equal to the electrostatic force, then what can you say is the net force acting on the particle? Then what can you say about the net force acting on the particle? It is, you see, well, in general, it can be anything. It depends. This is a special concept called as velocity selector. this is a scenario where you are considering electric field and magnetic field to be perpendicular to each other, and you are projecting the particle in the perpendicular direction for both. And you are choosing a scenario where the electrostatic force and the magnetic force get nullified. They get cancelled out, so that the total force acting on the charged particle becomes zero. If that is zero, what will happen to this charged particle? It will continue to move with uniform velocity in the same direction in which it was projected. As a result of which, what will happen is the particle will travel undeviated. Means, if at all there is a scenario where I give you a charged particle and say project it into a combined electric and magnetic field so that the particle travels undeviated. What kind of a scenario will you create? First, create electric and magnetic fields perpendicular to each other and adjust the magnitudes in such a way that the velocity of the particle, when you project it in the direction perpendicular to both the fields, it travels undeviated. So V will be equal to E divided by V. Means if you know the value of electric field and magnetic field, you will choose only those velocities with which you can project the particle so that it travels in the same straight line path along which it was initially projected. Am I clear? Yes. Okay, this is not about a specific particle. If at all you want any particle to travel without deviation, you have to do this. Okay. If you know the value of electric and magnetic fields that are existing, you will choose that velocity. You will choose a velocity which is dependent on the magnitude of electric and magnetic fields. Correct? Here. And till now we saw what will happen to a charged particle when it is projected into magnetic field. Now the question is, what will happen if you have a current carrying conductor itself placed in an external electric field? So write down the next heading as current carrying conductor placed in external magnetic field. Means so if at all, let's say this is how a magnetic field is already existing. Okay, into which there is a conductor like this that is placed. Okay, let's say the current is flowing in this direction and the length of the conductor, if I take it to be L, okay, let's say one of the electrons is there inside. So when the current is flowing in this direction, the electron, will you accept that it get drifted exactly in the opposite direction? So electrons inside a conductor drift in the direction opposite to that of current and they move with drift velocity. Okay. When this is the scenario, let's say the charge of the electron is E. Okay. Now I'm taking the axis of the conductor to make an angle theta with respect to the magnetic field. Okay. Now, what will be the force experienced by the electron? So what will be the force experienced by the electron? E into or minus E into Vd vector cross B vector. Accepted. Okay. Then what will be the force on n electrons? If one electron is able to experience this amount of fields, this amount of force, what will be the value of force experienced by the total electrons put together? Is this clear? Right. This will be equal to minus Ne into what is Vd vector? Vd vector, can I write it as L vector divided by T with a minus sign. Observe why. Because the direction of L vector is taken in the direction of current. So if this is the direction of L vector, then Vd vector is exactly the opposite direction. So I'll call it as minus L vector divided by T using the logic of distance divided by or displacement by time. So minus L vector divided by T cross, can I write this as B vector? Right. I'll take this T outside and minus outside. So can I write it as Ne divided by T into L vector cross B vector? What is N into E? It is the total charge. So the total charge flowing per unit time into L vector cross B vector. What is the total charge flowing per unit time called? Current. So I into L vector cross B vector is what is going to be the magnetic force experienced by the current carrying conductor. Are you able to understand this? So there are two important points that we discussed today. One is when a charged particle is projected into a magnetic field, it experiences a force of Q into V vector cross V vector. When a current carrying conductor of length L itself is placed in the external magnetic field, it experiences a force of I into L vector cross V vector, or this is in the vector form. Okay, if I have to write it in the scalar form, I will write it as I into L into B into sin theta, where theta will be angle between what? Theta is the angle between L vector and B vector. Length of the conductor. L is the length of the conductor. Okay. Because current and electrons always have opposite directions. Okay. So problems will be asked based on these concepts only. Okay. So the concepts that are left out are force between parallel, don't write it as of now, force between parallel current carrying conductors. Okay, then torque, then you have galvanometer, and galvanometer to ammeter and voltmeter. Okay, so these are all the topics that are left out, which I should be hopefully completing by this week itself. Okay, maximum I think we'll be able to complete it tomorrow, and on Wednesday we'll do problems based on these topics. Okay, any other doubt from today's class? Okay, so revise it and come. I'll see you. Anything, any doubts? Ritika, any doubts?
No, sir. Sir,
Okay.
sir, are you able
Ah.
to hear me? No, sir.
Sorry?
No doubt.
Okay. Okay. I'll see you tomorrow. Okay.